Okay, this is lesson 4. We're going to be talking about the outer planets. So here's our solar system. This is not to scale, not even close. But we're going to be talking about these outer planets. So if this is Earth, Mars, Jupiter is starting to get way out there. Jupiter is the largest. Next will be Saturn. And finally, way out on the edges, we'll see Neptune and Uranus. Super, super, super far away. So let's get started. All right, the outer planets, the first thing you need to know about all 4 outer planets is that they are all gas giants. And that means they're mostly made of hydrogen and they all have small molten metal cores. We don't know a ton about their cores, obviously, but this is our best guess at what's inside of there. Molten metal cores. So the first one, Jupiter. Now if you were to guess at Jupiter's size, you would probably guess it's smaller than it really is in relation to the Earth. If this is the Earth right down here, then this big thing is Jupiter. So, if this is Jupiter, this is the Earth, what's over here in the corner but the Sun? So the Sun, we should probably remember, is still enormous. But that's neither here nor there. So Jupiter is the largest planet. And there's no solid surface to land on. It's mostly made out of gas. If you were to parachute into Jupiter, I know it would take a long time to get down there, but you would just be falling deeper and deeper. Your ears would start hurting really bad. Your spacesuit would be crushed eventually. And you would find your way to that molten metal core. And you would be one with the core. No more you. You would be Jupiter. Now Jupiter is too small to be its own star. If Jupiter were 13 times the size, it would be a brown dwarf. If it were 80 times larger, it would be a red dwarf star. Stars are just giant balls of hydrogen, just like Jupiter. They're just larger, and gravity is able to crush them and crush the hydrogen into becoming helium in a fusion reaction. So it's too small to be its own star. It has 67 moons. If you Google Jupiter's moons, you wind up seeing, okay, there's Europa, Io, Ganymede, Callisto. You got all these moons. These here basically mean we haven't been close enough to take a good picture of them. We've had flybys that studied these, gotten good photos. We have not studied these yet. We don't know much about them. There's probably a lot of surprises, a lot of more things to discover about them. And this isn't it. There's more. And there's more. And there's more. And there's some that we don't even have decent pictures of, but they know that they're there. So for a total of 67 moons. Now, this spot you see on here is a large hurricane that's lasted over 300 years. 300 years is how long we've had telescopes to see it. So it may have been there 3,000 years. We just don't know what the deal with this spot is. Okay. Lastly, you should know 1 revolution is equal to 12 years. So 1 trip around the sun takes 12 years for Jupiter.
From a series of more than 4,000 photos taken by the Voyager space probes, this time-lapse film shows 10 days on the planet Jupiter. The planet's largest storm system, the Great Red Spot, is twice the size of Earth. By using this series of blue filter photos, scientists are able to study the motion of the storm in detail for the very first time.
Okay, we're going to move on to Saturn. That's enough of Jupiter. So, Saturn. Now, Saturn's the second largest planet. It's almost the same size as Jupiter. It's got these beautiful rings. Now, all these planets, all these gas giants have rings, but Saturn's rings are the ones you can see very, very easily. And they're really pretty. Did you know that the rings themselves are about 3 meters wide? So the distance between, the height of a basketball hoop is how wide that ring is. So very, very, very narrow, but very enormous around the planet. Now it has 16 moons, including Titan. Titan's the one that has geysers and an atmosphere and all sorts of interesting things going on it. And unlike Jupiter, who goes around the sun every 12 years, Saturn takes 29 years to go around the sun. Now, Jupiter, you should know, is 5 AUs from the sun. 5 AUs from the sun, whereas Saturn is, so 9.5 AUs from the sun. On to Uranus. Okay. Now Uranus is interesting. It's tilted on its side, so instead of being kind of tilted like Earth, so we have seasons, it ends up being tilted kind of 90 degrees. So it's rotating horizontal compared to everyone else. And one revolution is going to be 84 years on Uranus. It has 5 major moons, and it's 19 AUs from the sun. One thing I hope you notice is as the distance in AUs increases, it takes longer and longer to go around the sun once. So at 10 AUs, one revolution is 29 years. At almost 20 AUs, one revolution is more than double, 84 years. Now Neptune is very, very far away. It has 13 moons, 6 rings, and it takes 165 years to go around the sun. Now that is because Neptune is 30 AUs from the sun. So it takes 165 years to go around the sun once if you're at 30 AUs from the sun. So reviewing a little bit here, 10 AUs takes 30 years. 20 AUs takes over 80 years, and 30 AUs takes 165 years to go around the sun. So there are things out there that are 40, 50, 60 AUs from the sun, and they take hundreds and hundreds, maybe thousands of years just to rotate around the sun one time. They're moving very, very slowly. Now, the last part of these notes, exploring the outer planets, Voyager 1 and 2. Now, here's a picture that goes over all of our space exploration missions. This is called an infographic. It's a graphical way of showing what we've done in space. Now, all of the red lines are failed missions, missions that have not worked. So let's start with the moon here. If we zoomed in, we'd see that there are 79 missions, 73 missions that have gone to the moon. Most of them have failed. But the ones that we always talk about and are so proud of are these little tiny missions that have succeeded. So 73 missions went to the moon. Venus, we've had 43 missions to Venus. However, most of them have been failures. Okay. This infographic is great too because it shows, so this blue line here went around Venus, so it was a Venus flyby, but then it was a gravity assist kind of a deal. Then it went around Earth as another gravity assist, kind of like a slingshot. That was the Galileo spacecraft, which we crashed into Jupiter recently. So if we look at these inner planets, we see that there are a lot of missions. Mercury's had 2 to itself. The Sun, we've had 9 missions that go around the Sun. So there are a lot of missions on the inner planets. Mars, mostly failures again, but 40 missions have gone there. But as soon as we go past Mars, all of a sudden we don't have very many missions at all. Jupiter has had 9 missions. A couple of these missions went to Jupiter and then went to Saturn. Saturn had 5. And at the very outside of the solar system, Uranus has only had 1 mission go past it. 1 mission that photographed the ring and photographed how it's rotating on its side. You could see in the pictures how the clouds are rotating perpendicular to the way we expect. Neptune has only had 1 mission. This This spacecraft is only going to get to Pluto in July of 2015, so hopefully we hear about the news when that happens. But this dotted line right here, this is the Voyager spacecraft. The Voyager spacecraft launched from Earth, launched in 1977. It was one of the first spacecrafts to go past Jupiter and give, good pictures and everything else. And then it also went past Saturn and did other stuff in the solar system too. So here's what we need to know about Voyager. Voyager was launched in 1970 to study Jupiter and Saturn. Okay? And it was the very first spacecraft that we had out there that provided detailed images of these planets. The first time we'd ever seen them up close. So it was very exciting. They also studied magnetic fields, rings, weather on those planets. A lot of good science happened as they flew by. So that's the beginning. So after the mission ended, though, Voyager was made to keep going. And this is what's really special about Voyager. Voyager, in August 2012, so 30-some years after it was launched. It was actually launched in 1977. It exited the outer limits of the solar system and is now in interstellar space. We have something that has left our solar system and is outside of the control of the sun. And so it's in interstellar space. It's still going. The nuclear batteries, and here's the nuclear battery, will die in 2025. But Voyager 1 is really special in that it's our first thing that we've sent outside of the solar system. Here comes a video to explain.
Voyager 1 has left the bubble around the sun and entered interstellar space, space between stars.
It's amazing that Voyager has operated 36 years. Launched in 1977. Traveled past the gas giant planets. And now off into interstellar space. A radio telescope took a radio image of Voyager 1 spacecraft, slightly over 11 billion miles from Earth. And it's a very small radio dot amongst the sea of darkness.
We have an instrument on Voyager which can measure the density of the ions, the plasma which is out there. In March of 2012, it turns out there was a massive eruption from the sun which eventually reached Voyager 1 in April of 2013. When that blast wave reached Voyager, it caused the plasma around Voyager to vibrate or oscillate in a certain particular tone. Literally, they're the sounds of interstellar space. And by measuring that sound wave, we could measure the density of the plasma, and we're amazed to find out that we were in interstellar space. This is a historic milestone in the great journeys of exploration that have been undertaken by humankind. Well, it is quite remarkable when you think about it. It's far off now at ever increasing distances. There's this little vehicle, two of them, which were built here many years ago and launched 36 years ago, now on a journey that will basically last for billions of years.
Finally, here's a brief explanation of what it is, does, and where it went.
But Voyager cruises so far from the sun that it cannot depend on solar power. Instead, it has a small nuclear power plant, quarantined from the rest of the ship. Voyager's passage by Jupiter accelerated it towards a close encounter with the planet Saturn. Saturn's gravity will propel it on to Uranus, and in this game of cosmic billiards after Uranus, it will plunge on past Neptune, leaving the solar system and becoming an interstellar spacecraft.